Okay? So you're estimating C prime of 5. That's right here between 3 and 7. Use the points closest. So you are just going to do 80. You've got the point 385 and 769. So we'll have 85 minus 69 over 3 minus 7, or 69 minus 85 over 7 minus 3, either one. To speed us up a little bit here, I had already put a lot of this into Desmos. So that is going to give us -4. This is calculator active. You technically don't even have to reduce that, but it is calculator active, so I probably would. Sometimes ask you to interpret. They don't actually ask that here. They do say include units. That means they're giving you a point for units most of the time. So units, the top two numbers, 85 and 69, they are degrees Celsius. And the bottom, 3 and 7, those are minutes. So we get -4 degrees Celsius per minute for that. Maybe.
What if you just wrote out degrees Celsius?
That'd be fine. I'd probably put Celsius. But, in fact, if you want, you could just use exactly what they use from the table, even though it's long. And then you know pretty much you've got it right for that. Okay, everybody good here? On table problems, this is usually the first question. It's usually slope. Not always, but lots of times. Okay, now we're actually pretty good with some Riemann sums. You guys do pretty well. This one has a little bit of a different thing right here. It asks us to use a left Riemann sum from 0 to 12, and then it tells us to interpret the meaning of 1 over 12 times the integral from 0 to 12 of C of t dt. We're doing just the integral from 0 to 12 of C of t first. And we're going to use squiggly marks because it's not actually equal. This is approximation. So with a left Riemann sum, we're finding the width of the rectangle, which would be 3. And we multiply by the height, which is going to use the left endpoint there, since it's a left Riemann sum. And then here we'll have 4 times our left Riemann sum, or left point. And then here we'll have 5 times our left. So we got 3 times 100 plus 4 times, what was it, 85 plus 5 times 69. Okay. Technically, you don't have to give a number, but it sure does make it a lot easier to interpret the meaning if you have a number. And this is calculator active, so if you type it into Desmos, you should get 985. Okay, now, notice they don't ask for units right there. That is because C itself is degrees Celsius. And when I integrate, that like goes back up, right? So like C is degrees Celsius. C prime is degrees Celsius per minute. C double prime is degrees Celsius per minute per minute. To integrate C, you get like degrees Celsius times minutes, which doesn't make it, it's not a unit that makes any sense, right? So they don't ask for units there. But they do ask you to interpret the meaning of 1 over 12, integral from 0 to 12, C of t, dt, in context of the problem. They're probably looking for units here, right? What is that going to be, the 1 over 12? It's average value, right? When you see that 1 over length of the interval, it's average value of C of t. So 1 over 12 integral from 0 to 12 of C of t dt is the average. And so it's average value of what? What is C of t? It's degrees Celsius, so it's the temperature, right, of the coffee. So it is the average. You can put value of the temperature, but that really is not worded very well. The average temperature of the coffee from T equals 0 to T equals 12 minutes. There. And you technically don't even have to find the value. It doesn't say that you have to give it. You can find it if you want. And then if you find it, you can use that number instead of this here. But I think this is going to be sufficient. This is like bare minimum work here. Everybody good here? All right, let's keep going. For C, from 12 to 20, the rate of change of the temperature of the coffee is modeled by C prime of T, and it gives you that equation where C prime of T is measured in degrees Celsius per minute. So this is our rate, right? Find the temperature of the coffee at time T equals 20. Show the setup for your calculations. So this only applies from 12 to 20, right? I've got a rate. This is degrees Celsius per minute. The question is asking to find the temperature, right? That is in just degrees Celsius. What do I need to do on this problem? I need to integrate because I'm going from a derivative from a Celsius per minute, and they're asking me for just temperature, not a rate, but just the temperature. So I'm going to integrate here. Now, are they asking me for like over a time period or at a specific time? At a specific time. So at a specific time means that I need to know a starting temperature plus the interval, right? So I can know the starting temperature because at 12, the temperature of this coffee was 55 degrees, right? That's given in the table. And I want to use 12 because this does not apply until you get to 12, right? So I'm going to do 55, because that is our temperature, plus the integral from 12 to 20 of C prime of T dt. You are just going to type this into the calculator. So I have already put, I called it D and D sub 2 because it will not work if you put C prime in. I use D for derivative there. Use whatever you want for letters, but if you try to type in C prime and then take a derivative, like integrate it, I don't think it works. So I'm going to have 55 plus integral from 12 to 20 of D of T dt, and I get 40.329. These are the numbers you guys were getting whenever you did these, right? Okay. Make sure I'm not double checked my work here. And that is degrees Celsius, although I don't think they're giving a point for units on that. Doesn't hurt to put it there. That's all you got to show. All the work is done in the calculator. Okay, everybody good there? All right, and then for the last part, it says for the model defined in part C, it can be shown that C double prime of T is this from 12 to 20. Determine whether the temperature of the coffee is changing at a decreasing rate or an increasing rate. And give a reason for your answer. This is decreasing rate, increasing rate. This is that chart, right? So C is your temperature of your coffee, right? C prime is your rate. C double prime is your rate of rate. So we want to know whether C prime is increasing or decreasing, right? We want to know if the rate is increasing or decreasing. Do they even have to give you second derivative here? I don't think so.
You can find that by doing positive and negative. See double prime.
Right, so you can use this, so you can do that, but they also gave you hold on, let's see, because it says temperature of the coffee is changing at a decreasing rate or an increasing rate. So you can use C prime or C double prime here. So this is concavity. You can really use either. You don't necessarily have to mention concavity. But if we look at our graph, if you look at the second derivative here, it's pretty small, but it is positive, right? So you could say, since D, don't call it D, call it what they call it in the problem. Since C double prime of T is greater than 0 for 12 less than T less than 20, the temperature of the coffee is changing at increasing. Or, since they gave you C prime, your other option is to look at just C prime right here, and you can tell from 12 here to 20 that C prime is increasing. So you could say, since C prime of T is increasing for 12 less than T less than 20, the temperature, same conclusion, right? You can just write what I have the second part of that. So either one of those are options there. Is that the answer that was on the key? So, I feel like